Okay. So this was one of the probably the hardest multiple choice questions, and that asked. Okay. What was the current? And there were actually two questions about this particular circuit, right? But the question was, what's the current in the 10 ohm resistor, which is the one at the end of this little parallel section. So we have a 4, a 6, and a 10 ohm resistor, and then in series, a 2 ohm resistor and a 12 volt battery. Okay? Chris, that is my favorite marker that you have in your hand. Seriously, that's the one you choose to borrow. So first and foremost, probably the easiest thing would be to figure out the parallel resistance for that section. And you can do 2 at a time, or you can just do all 3. They're all parallel. So 1/4 plus 1/6 plus 1/10 equals 1 over R total for that parallel section. And I think that's the answer for one of the other questions, right? What is it? Oh, Miss Nick. .94, 1.93 is the resistance, 1.9-ish. Okay, just for that parallel section. So the total resistance would be 1.94 plus 2. So resistance equivalent equals 3.94. And if we do V equals IR, the voltage is 12. The current coming out of the battery is what we'll solve for. Divide 12 by 3.94. You get a current of a little over 3 amps coming out of the battery. So it would be fussy 3.05 amps. Now that 3.05 amps will split 3 different ways by 3 very different proportions, right? So it'll split in a, this would be very difficult to do, in a 10 to 6 to 4 ratio. Notice I flipped it, right? Because the easier the resistance, the more the current. So that would be difficult at best. Another way to solve these Ohm's law problems is to just kind of look at what you know, and every single problem is unique, and to fill in as much information as you can while you're sort of analyzing. So we could figure out the voltage drop right here because we know the current resistance. So that's going to be about 6, right? 6.1 volts. So we had 12 available, right? We already dropped 6 right here. So what are you going to drop across each of these parallel sections? The other 6, correct. So since we really care about the 10 ohm resistor, I'll just put it here. Or to be more precise, about 5.9 volts. Now you can just solve for the current in that parallel pathway. And you could do these as well. Might be kind of good for a little check to do that. So 5.9 divided by 10 is 0.59 amps. So that's how you found that one. 5.9 divided by 6 is going to be about 1.98 amps. And 5.9 divided by 4 is about 1.5 amps. So if I add up 1.5, 0.98, and 0.59, what should I get? If I add all 3 of those currents, this plus this plus this, all 3 of those currents, the purple currents, should give you what? No, the 3. You should get this. The 3.05 splits up into 1.5, 0.98, and 0.59. Does that make sense? That's where those came from. So So when I add those up, I get 3.07 amps, which is plenty close enough. Okay. So I went fast. Take a look and tell me if you have questions. Yeah, the 0.59 volts applies to all of the parallel sections. That's the deal with a parallel circuit, is it provides the same voltage, and then the current adjusts depending on the needs of the appliance. Voltage is the same. Every time you plug in an appliance to a household outlet, you get about 110, 120 volts. Other questions about multiple choice before we move on to the free response? Yes. On which version, Harper? 7, version 2. Yep. A lot of kids got these couple of questions wrong because you didn't read it carefully enough. So these were questions about the current in a series and or parallel resistor, not the resistance equation. So since Friday I asked you about current, a smart physics student would predict the kind of questions I might ask tomorrow. Voltage or resistance, very good. So make sure you know how to analyze all three. Harper, this question asked about the current in a parallel circuit. So we've got like this, right? Okay. And the current is I1, I2, and I3. What's the relationship between the total current and those individual pathways? If you see the picture, I know you can figure it out, right? Yeah. I1 plus I2 plus I3 is I total. For a series circuit, and maybe it would be good to review voltage and resistance as well. For a series circuit, here's I total, right? And we'll call this I1, I2, and I3. Okay? So what's the relationship for current in a series circuit? Only one path, all equal, all the same. So I total equals I1, which equals I2, which equals I3. How about voltage now for these guys? So this is V1, V2, V3, and V total. Relationship between V total, V1, V2, and V3. Same? Equal. This equals this equals this. Okay. And how about here? V total, V1, V2, V3. What's the relationship? Adding them up, right? It's summative. So 1 plus 2 plus 3 equals total. So good for tomorrow? So now let's look at free response. Cost for appliance, do you need to see that one, or are you pretty comfortable? That's just a factor label problem. The answers for version 1 and version 2. Version 1, the answer was $21.02. And for version 2, $2.10. And do use common sense here, guys. For a night light, somebody got $2,100,000. It was a decimal place issue. I mean, they just shifted the decimal, like multiplied by 1,000 instead of dividing. But use some common sense. Really? A night light? Well, what if I leave it plugged in? How many of you have a night light in your room that's plugged in and left on 24 hours a day? It's okay to admit that. It's fine. Thank you, Josh. All right. Yeah, if it costs $2 million, yes, there's something wrong. All right. Can I go on? Is everybody okay with number 11? All right. Number 12 on version 2, we'll do that one. this compound circuit, actually you guys did quite well with this overall. I was very pleased. So I will very quickly review this. They were a little bit different, but I think they had the same answer. Version 1, version 2. So we have 4 ohms, 4 ohms, 2 ohms, 3, 3, 3, 3, 1 down here, and a 12-volt battery. Okay. So find the equivalent resistance. Do the parallel sections first. This one, 1/3 plus 1/3 plus 1/3 equals 1 over what? 1. So the equivalent resistance here is 1 ohm. The equivalent resistance here, 1/4 plus 1/4 equals 1/2. So this is 2 ohms. So now if we look at each of these parallel pathways, sort of the greater pathway, I have 1 plus 3, so that's 4. And here I have 2 plus 2, so that's also 4. So the equivalent resistance of those two pathways together, just like this, is going to be 2 ohms, and 2 plus 1 equals 3. So what's the current coming out of the battery? If the total resistance is 3, 4 amps, yes. And then that's all I asked was for the equivalent resistance, which is 3, our equivalent. Tomorrow I might ask you to show that you know how to find how the current and voltage splits up. Could you do that? What's the voltage drop right here? 4. 4 times 1, good. What's the, what happens to the current coming in right here? Since we know that these are equivalent pathways, splits evenly, good. So that's 2, and this is 2, right? So what would the voltage drop up here be? What would the voltage drop across this little parallel section be, since it's like 2? Yeah. And the voltage drop across this parallel section right here, 2 times 1, yeah. And right here, 2 times 3. So now if you go across any loop, you should get 12 volts. So we have 4 plus 2, 6, plus 6 is 12. 4 plus 4 plus 4 is 12. Yay. You seem easy now, right? Yeah? Yeah, those of you taking AP Physics will, next year, will beg for these to come back. Because the stuff you're going to do is really hard. If they're really fun, though, oh yeah. I've subbed for Mrs. No, otherwise you wouldn't sign up. I've subbed for Mrs. Portingod every time she's had children, and so I made some really fun, really complicated circuits. That's where some of yours come in your really hard circuit packet. So you might see some of them again. The current question, where current splits up, is everybody okay, or have you figured out if you did something wrong? Can we go on to the parallel batteries? That one? Okay. If you have questions about the current split up thing, go ahead. Come on up and I'll show you. There are a couple of right answers for this, by the way, depending on how you set this up, so I will try to. Sure. 9 volts, 1 ohm, 2 ohms, 4 volts. Yeah, I made this one almost too simple because there were a couple different ways you could solve it. All right. The first thing you should do is figure out the direction of the current. What did I do with that one? Okay. So current goes this way and this way, right? Out of the positive into the negative. It would make sense then it would come together and do that. And then split, and then split. So we'll call this I1, I2, and I3. Did I do that right? Yeah. Okay. So you have a junction rule and a loop rule. Yep. Oh, see, I did that. The junction rule then would be 1 plus 2 equals 3, right? So now we start doing loops. And choose loops that are easy. So if I'm looking here, this loop is all in the same direction, and this loop is all in the same direction. If you do the big loop, you got some negative current going on there, right? So you have to keep track of the positives and negatives. It can be done, it's just fussier. So let's do the bottom loop and the top loop. So the bottom loop, I have 4 volts, and it's just going through this single 2 ohm resistor, right? So 4 volts must equal I times R, I3 times R, which is 2. What's I3? 2 amps, yeah. 2 amps to the right. Okay? And then let's do the top one. Sure. This loop right here, this bottom loop, following the arrows, correct? 4 volts has to all get dropped right here. To stay in this loop, you got to drop the 4 volts. That's the loop rule. Whatever loop you choose, you got to use up the voltage. So this 4 volts gets dropped right here. So 4 volts equals I times R times 2 is 4. So that's 2 amps. Now let's do the top loop. Now we already know that this was 2 amps here, so we know that 4 volts was dropped right here, correct? We just defined that. So now let's look at the top loop. 9 volts is available, and so that means between these 2 resistors, I've got to drop 9 volts, right? I already dropped 4 here, so how many volts am I going to drop here? 5. Now do a little V equals IR just for this resistor, right? We already know the current here. So 5 volts equals I1 times R. What's the current? 5. 5. Okay. Now there's another way that you can solve this when you get 2 and 13, but I think this is the easiest way. Okay? The answers for version 1, it's 6 and 3 amps, and then you also had to give directions. So if you got something different, like with bigger numbers, let me know, and I can show you whether or not it checks. Okay? The B test will be very similar to this. Same pre-response, we'll have a money question, probably a conservation of current question, a compound circuit, and something like this that's more complicated with a couple batteries. Okay. All right.